Alright, so this time we're going to do motion problems with linear systems. Here we go. Okay, so the riverboat alert takes 6 hours to travel upstream, but only 4 hours to return. Find the speed and the current of the riverboat. Okay, so most of us are used to D equals RT. D, RT, right? D equals RT. But we're going to add a new component to that, and that's going to be the current. Okay. So we're going to make a table like this to start. So we're going to fill in all our information. So a riverboat alert takes 6 hours, so time 6 hours, to travel 120 kilometers, distance 120, upstream. Okay, now upstream, okay, that means you're fighting the current. The current's working against you, okay? So current is going to be minus C, because I don't know exactly what it is, but I'm fighting against it. But it only takes 4 hours to return. So again, distance is going to be 120 because we come all the way back. Time changes to 4, and because this time we're going with the current, it's going to be plus C. So we got to fill in our rates. So we got a lot of pieces missing here, or so it looks. Okay, so I usually make the X rate and Y is the current. I just use R's and C's, it's easier, but you can do whatever. Alright, so to set up the equation, we're going to start with distance equals, let me get rid of that. We're going to start with our distance for the first equation, 120 equals. Now I'm going to work with what they gave me here. The regular number is what's going to lead us off. So we're going to start with the 6. Now the rest of the trash left over on in that line goes in a parenthesis, so R minus C. Okay. Now for the second equation, we're going to do 120 again is equal to, so again, my time is what they gave me, so 4 with R plus C. Now, we could distribute the 6s and the 4s and, you know, do all that, but there's an easier way, and it's this. Notice how my C's here look ready to go if I could add down. The problem is the 6 and the 4 on the outside. So I'm going to get rid of them instead of distribute them. I'm going to divide this one by 6s and this one by 4s. So I'm going to get 20 is equal to R minus C. And then I'm going to get 30 is equal to R plus C. Okay. Now at this point, my C's, they're set to go. So I'm just going to add down. So 50 is equal to 2R, and then divide by 2. So 25 is equal to R. Now when we go back, I would always pick the R plus C equation. It's the easiest one to use. 30 is equal to 25 plus C. Minus 25s. So 5 is equal to C. So my rate is at 25. The current is at 5. And there you go. It's that simple. These things are really, really easy. All right, let's go to the next one. All right, so here we go. Anne can paddle her canoe downstream. All right, so we got, I always start with D, R, T, C. It's going to look like this. X is rate, Y is current. Okay, so here we go. Anne can paddle her canoe 15 miles downstream in 2 hours. So distance is 15. Downstream is plus the current. The current's helping you along. And your time traveled is 2 hours. Okay. Now, then we go to the other side. The return trip upstream takes 3 times as long. So we're going to go minus C because we're going upstream. Distance is going to be the same. We come all the way back. But 3 times the time. Well, 3 times 2 is going to be 6. So we have this. Okay. So now let's take these out. 15 equals, so they give us a time of 2 times r plus c. For the second equation, 15 is going to equal 6 with r minus c. So again, let's distribute, or just divide. We're not going to distribute. Divide this by 2. We're going to divide this by 6. So we're going to get 7.5 equals r plus c. 15 divided by 2 is 5/2, which is 2.5. So 2.5 equals r minus c. Okay. So now at this point, we're going to add down. The c's cancel. So we're going to have 2r is equal to 10. Divide by 2's. So 5 is equal to r. Now, like I said, I always go back to this equation right here. So 7.5 equals 5 plus c minus the 5's. So 2.5 is equal to c. So 5 is the rate. 2.5, come on, write the point, is your current. All right, so there's that one. Oh. And we're rotating. Okay, so let's go to the next one. Okay, weather service plane flew 2,100 kilometers east. Okay, so we're dealing with this, so DRTC. Okay. All right, so a weather service plane flew 2,100 kilometers east. So distance 2,100 kilometers. With the jet stream as a tailwind. The tailwind pushes the plane along, so plus c. And then back again. Okay, so it comes all the way back, so 2,100. And we're going to fight the current on the way back. Okay, the eastbound trip took 2.5 hours, so east is 2.5. And the westbound trip took 3.75 hours. Okay, what is the speed? And again, over here we got rate, current. All right, so let's take out our equation. So 2,100 equals 2.5 with r plus c. 2,100 equals 3.75 r minus c. All right, so there's our equations. All right, so what we're going to do, let's get rid of those things out in front. So divide by 2.5. We're going to divide this by 3.75. Okay, so 2,100 divided by 2.5, it's going to be 840. And 2,100 divided by 3.75 is 560. All right, now we're set. C's are ready to go. Let's add down. 2r equals 2. It's going to be a 0. This is 0. 1,400. So when I divide by 2, scooch this one more time. So R 700 equals R. All right, now we're going to go back here. Okay, so 840 equals 700 plus C minus 700. So 140 equals C. So 700 is your rate. 140 is the current. There's that one. All right, let's keep moving. Okay, in 4 hours with a tailwind, a plane can travel 1,200 but only 800 back. Okay, so this one's a little different because we don't come all the way back. All right, so here we go. In 4 hours, so time is 4 hours, with a tailwind, plus C, An airplane travels 1,200 miles or kilometers, okay, but only 800 kilometers in the same amount of time back. So this is going to be also 4 against the current, like so. Rate current. Okay, take out the equation. 1,200 equals 4 with R plus C. 800 equals 4 R minus C. All right, so let's divide this out. Divide by 4s. So 300 equals R plus C, and 200 equals R minus C. Now again, my C's are ready to go, so we're going to add down. 500 equals 2R. Divide by 2's. So R equals 250. Now again, I'm going to go back to this. 300 equals 250 plus C minus 250. 50 equals C. So my ordered pair, 250 for the rate, 50 for the current. So there's that one. All right, let's go to the next one. All right, so one thing they've left off in this problem is the week 5 total, so I put that in. So week 1 of a football game, the concession stand sold cheeseburgers for 50 cents each and hot dogs for 75. Tim purchased cheeseburgers and hot dogs and paid $11.50. Week 5 football season, this concession stand raised the rates and the cheeseburgers were 55 cents, hot dogs are now $1. Tim again purchased the same amount of cheeseburgers and hot dogs from week 1. How many burgers and dogs did he buy? And again, the week 5 total was $14.05. So this is a scenario problem, okay? Because week 1 scenario says, and we're going to make X the hot dogs, let's make Y the burgers. Okay, so let's start off. We're going to have 0.5X for the plus 0.75Y equaling $11.50. Okay, in week 5, we're told that hot dogs are now 55 cents each. Burgers are now $1, and we paid $14.05. So here's our system. So now I'm going to pick the Y's to go after here. I think they're going to be the easiest. So I'm going to do the top by 1s, bottom by 0.75. So 0.5x plus 0.75y is equal to 1150. All right, so here you go. Here's where the fun calculator stuff starts. All right, so get my calculator. Let's clear that out. So we're going to do 0.55 times 0.75. I get 0.4125x plus 0.75y is equal to, now 1405 times 0.75. I get 10.5375. Some real fun numbers here, huh? All right, now I'm going to tweak the lower equation so I can make things cancel. So here we go. So let's subtract 0.5 minus 0.4125. I get 0.0875x. Y's cancel. Now I'm going to do 1150. Nope. 1150 minus 10.5375. I get 0.9625. Now I'm going to divide by 0.0875. So divide that by 0.0875. I get x is equal to 11. All right, so let's pull this back a little bit. We're going to go over here. All right, so now let's go back. Pick the nicest of the two equations. I'd probably go here. So 0.55 times 11 plus y is equal to 1405. Time this, so 0.55 times 11. I get 6.05 plus y equals 1405. Oops. Okay, now I'm going to move minus the 605. Therefore, y is equal to 8. Yay. So we have 11 for the hot dogs. He bought 11 hot dogs, and he bought 8 burgers. So there's that one. Okay? Go on to the next one. Okay, this one, the length of a rectangle is equal to the base of the isosceles triangle. The width of the rectangle is equal to the lengths of the sides. Okay, so first thing we do, let's draw the figures. Okay, we have a rectangle and we have an isosceles triangle, so these sides are equal. Okay, the length of a rectangle is, so we're learning about the length, equal to the base. So let's make these x's. The width of the rectangle is equal to the lengths of this. So this is y, and these are y's. Okay. Find the dimensions of the figure if the perimeter of the rectangle is 22 and the perimeter of the triangle is 14. Okay. So let's set up the rectangle, but remember we have y's and x's over here. So we have 2x plus 2y is equal to 22. For the triangle, x plus 2y is equal to 14. All right, so I'm just going to use elimination here. I'm just going to tweak the bottom equation. So I'm going to have x, the y's cancel, is equal to 8. Okay, now you can pick any equation you want. I'm just going to go back to this equation, take out the negatives and put the pluses back in because I can do that. So I'm going to say that x plus 2, or I'm sorry, x is what I solved for. So 8 plus 2y is equal to 14. Minus the 8's. 2y is equal to 6. So y is equal to 3. Okay, so the dimensions, the rectangle. Okay, your length is going to be 8. Width is equal to 3. The triangle. For the triangle, the base is going to be 8 and the legs are going to be 3's. All right, so there's that one. All right, so that's the end of this video. Hopefully you learned a lot, and I'll see you next time.